Hello everybody, my name is Brandon Renwick and this is my Project 2 presentation on network intrusion detection. So I hope you guys enjoy it. So just kind of a general workflow overview. I just kind of wanted to show what my initial process was for doing this project. I performed in the beginning, you can see just regular pre-processing that needed to be done, adding columns, all that good stuff, and then doing the train and test split. However, pretty early I had to break away for each different model, both the fully connected neural network as well as the convolutional neural network. Convolutional being on top and then connected being kind of on the bottom right here. The reason being is because the initial shape of the X inputs differed. One just took in the regular data frame inputs, and the convolutional neural network actually needed the data to be reshaped more something kind of relating to an image, and we'll get to that later. Aside from that, it was pretty straightforward. I set up an initial model design that worked, and then I fine-tuned until I got the best result. The hyperparameters definitely differed. For the regular neural network, I focused a lot more on just activation functions, optimizer, and layer count, whereas the convolutional neural network, the biggest thing I messed with was kernel number and size, as the other hyperparameters didn't really seem to affect performance that much. And then testing and evaluation kind of came back at the end, as we were interested in the same metrics regardless of the model's design and architecture. Okay, so let's talk about the overall architecture of the neural network first. The input consisted of 120 column values, and that number is so high because all of my symbolic column values were broken down into binary features, and each binary feature could have multiple columns. So I didn't actually increase the data amount or anything like that. I didn't add any new columns, so the 120 columns is the same data set that we used in the beginning. The hidden layers, respectively, I have 4 of them. That was my best performing setup, was going from 80 to 60 to 40 to 20 with the tan-h, if I'm saying that correctly, function. And then my output was actually just two values with the softmax function. And it's worth noting that my output consisted of a kind of binary feature instead of just a straight 1 or a straight 0. And that was because I had to do that to prevent errors when using the categorical cross-entropy loss function. So moving on to the convoluted neural network, we have an input, which is a 2-dimensional array. I converted basically the X or the input values from the data frame into an array, and then I reshaped the array per, I believe it was the lab on convoluted neural networks, had some snippets in there about shaping non-image related data into kind of a quote-unquote image. Next, I had 2 kind of pairs of convolutional 2-dimensional layers. So it leads with the convolutional 2-dimensional, and then it follows with a max pooling layer. The initial kernel size I have was 6 with a pool size of 4, and then I had another one with a kernel size of 4 as well as a pool size of 4. And that was all done before flattening the data. And then that's when I fed it into this kind of densened layer with 1024 neurons with the ReLU function. I dropped it out at 0.5, and then the output was the same thing, softmax function with the 2 neurons. And the output did not need to change for the convolutional neural network. So what were the results? Well, I got really high accuracies initially for pretty much every model. Ironically, the neural network performed better than my convolutional neural network, although I have suspicion that that's probably just me. But my neural network, the best score I got was a 0.997. And the convolutional neural network was a 0.97, which I'm considering what the project kind of entails is really good, and it can really kind of prove useful to solve the initial problem presented. There we go. A few challenges that I encountered. So number 1 would be the high initial training accuracy. And I know that doesn't really sound like a challenge. However, I spent hours hunting for a problem that hopefully didn't exist. The first thought I had was that I overtrained my model severely, but it turned out that I used early stopping. I kind of checked for that, and I didn't really find any evidence to suggest that it was overtrained. Furthermore, I just kind of spent a bunch of time that I didn't need to validating every data conversion to make sure that I wasn't screwing up somewhere. And at the end of the day, the accuracies were just high. So that was kind of interesting because normally you would kind of start at a low accuracy and then through fine tuning get to a higher level. But this one came right out of the bat with at least a 0.97. So that was kind of interesting. And then the second one is that convolutional neural networks are very different than regular neural networks. The data shape was different for the input. That took me a while. And I'm definitely just more unfamiliar with convolutional neural nets. My parameter tuning was a lot of guess and check, things that I just kind of would slam the compiler with and go, oh, can't do that. You know, a lot of inconsistencies with trying to take one shape of a matrix and putting it in with an incompatible shape. So kind of hitting my head against the wall a little bit, but those are really the main challenges in this project. Otherwise, I had a lot of fun with it, and I'm really glad to finally get my feet wet with convolutional neural nets. And that's the end of my presentation. So thank you guys. I hope you really enjoyed it, and best of luck.